All right, let's dive into a concept that is quite literally the invisible architecture of pretty much every modern network out there: VLANs. I want you to think of them as virtual walls. Today, we're going to figure out how these walls get built, and more importantly, why they are so absolutely critical for bringing some serious order to our digital world. So, to really wrap our heads around VLANs, let's start with a little thought experiment. I want you to picture your office, but with one massive change. What if there were no walls? I mean, zero. No cubicles, no private offices, just one gigantic open room. Can you imagine the chaos? You'd have the finance team's super sensitive budget talks happening right next to the sales team's loudest client calls. Every single conversation, every little whisper would just echo across the entire floor. It would be a constant buzz of noise. It's not just inefficient, it's a security nightmare. And you know what? In the networking world, that is exactly what we call a flat network. So, how in the world do we fix this digital free-for-all? Well, we do what any good architect would do. We start building some walls. Except, in our world, these walls aren't made of drywall. They're made of data. They're completely virtual. And that, my friends, is where the VLAN, or Virtual Local Area Network, comes into play. And this is the really cool part. A VLAN lets us take one big physical network and just digitally slice it up into smaller, totally isolated groups. So even if the marketing and engineering teams are plugged into the very same physical switch, VLANs can put them in two completely separate virtual rooms. Now, before VLANs, it was a totally different story. Anytime a device sent out a broadcast message, which is kind of like a computer shouting, "Hey, is anyone there into the room?" it was heard by every single device on that network, and each of those devices had to stop what it was doing just to listen. This giant, noisy room is what we call a single broadcast domain. And boom, here's the after picture. With VLANs, we've put up those virtual walls. Sales is now in its own bubble, engineering is in another, and HR is in a third. Now, when a computer in the sales VLAN shouts out a message, guess who hears it? Only the other devices in that same sales VLAN. All that noise, it's contained, it's clean, it's efficient, and it is so much more secure. Okay, so this is great. We've got our virtual walls, our separate departments are set up. But how do people actually get into their virtual offices? And how do we connect the different departments when we need to? Simple. We need doors and hallways. So let's break this down. On the left, we've got an access port. Think of this as the private door to an employee's office. It connects just one device, like your PC or a printer, to one specific VLAN. That's its only job. But a trunk port, over on the right, that's the main hallway of the building. It's designed to carry traffic from multiple VLANs all at once, connecting switches to other switches. It uses these special digital tags to make sure the data from sales never accidentally ends up in the HR department. So, we have walls, we have doors, but how does the building's management system, I'm talking about the network switch, how does it actually enforce all these rules and keep all the chatter contained in the right rooms? Well, the secret sauce is something called a filtering database. You can just think of it as a MAC address table. Now, a MAC address is just a unique ID for every network device. And this is where it gets really smart. Instead of having one giant phone book for the whole building, the switch keeps a separate and independent phone book for each and every VLAN. This means the switch knows exactly which devices belong to which department, and it simply will not forward traffic between them unless it's explicitly told to. And the results of doing this are huge. I mean, look at this chart. The biggest slice here is broadcast limitation. That is our number one win. By cutting down on all that network chatter, we boost performance for everybody. And the other benefits just fall right into place. We get isolated traffic for better security, we create smaller, more manageable network zones, and, as we're about to see, we force all the communication between departments to go through one single controlled checkpoint. Right, so this brings up a really important question. If all these virtual departments are totally isolated from each other, what happens when someone in sales absolutely needs to send a file to someone in finance? How do they cross that divide? Well, they definitely can't just shout down the hallway anymore. Let's walk through it. Say a PC in the sales VLAN, we'll call it VLAN 10, needs to get something from a server in the finance VLAN, VLAN 20. The PC knows that server isn't in its local room, so what does it do? It sends the request to its manager, its default gateway, which is a router. That router is connected to both VLANs, and it acts like a secure go-between, checking the rules and then forwarding the message to the right place. And this right here is a golden rule of VLANs you've got to remember. A device will only use that shouting method, the ARP request, to find other devices inside its own virtual room. For anything or anyone outside its own four virtual walls, it knows it has to go through the official channel. It has to talk to the router. And this quote really hits the nail on the head as to why. See, VLANs operate at what we call layer 2. That's the local neighborhood level. But to talk between different neighborhoods, you need a device that understands the entire city map, and that's a layer 3 device, like a router. The router is the gatekeeper, the traffic cop, that directs everything between these separate virtual networks. So let's tie this all together. What are the big takeaways? First, security. We build virtual walls to isolate sensitive stuff. Second, performance. We cut down all that network noise, which frees up speed for things that actually matter. Third, management. We can now group our network by who does what, not just by where they plug in their cable. And when you put that all together, you realize that understanding VLANs isn't just some techie skill. It is the absolute foundation for building any modern, scalable, and genuinely secure network. So we've established that VLANs are the virtual walls of our network, which leaves us with one last thing to think about. If that's true, how do you decide who gets a key to which room? And how do you enforce those rules? But that, well, that's a whole other topic for another day. Thanks for hanging out with me.